Welcome back. So we're going to talk about side-side angle problems, and those problems are ambiguous. They may form 0, 1, or 2 triangles. I've only got 2 examples here, and I'm going to try and talk about 2 different ways that we can know whether they form 0, 1, or 2 triangles, and we get the same answer either way. The setup is important that we always put. I'm going to draw a scaling triangle here. And I'm always going to assume it makes a triangle until I know otherwise. I'm going to put the known angle in the lower left-hand corner, and I'm going to put the side across from it, across there, and the other side has to go over here to the on this side. It's not the base. And then I'm going to fill in that. So this was B, and this side was little a. So I'm going to use big A, big B, and big C instead of alpha, beta, and gamma. So now I'm ready to use my law of sines. So let's actually first talk about the method where we find the height. So I'm going to drop an altitude here. This is going to be h, and sine of 49 degrees is going to be h over 7. So 7 sine of 49 degrees is equal to h. So I'm going to figure out what that is here. 7 sine of 49 degrees. And it's always going to be this side over here times the sine of this angle down here when we've set it up this way is going to be this h that drops straight down. So this is going to be about 5.28. 9 is bigger than 5.28, so we definitely have one triangle here. And this height is smaller than this base and smaller, which is smaller than this side here. So we should have only one triangle, but let's go ahead and prove that. So we're going to use the law of sines here to try and solve for angle A by saying sine of angle A is to side A as sine of angle B is to side B. So sine of angle A is 7 sine of 49 degrees over 9. 7 sine of 49 degrees over 9. I do not want to round this. I immediately want to take the arc sine of this answer here. And let's say that A is equal to 35.9. I'm just going to use all of this. Degrees, right? I know that I'm going to round that. So I'm going to round that to the nearest hundredth of a degree. Right? And then that means that 49 plus 35.94. This is 35.94. So we're going to take 180 minus 84.94. It's going to give me 95.06 for angle C. Then I'm going to say that I need to find side C over here. So I'm going to use C is to sine of 95.06. This is the only time that I want to use a rounded answer here in my law of sines. And I'm going to use the pair of things that I know exactly. 9 over sine of 49, because neither of those things are rounded. So C is going to be equal to 9 sine of 95.06. Now, if I wanted a more exact answer, I could leave all of this in there and figure out exactly what sine the angle was to a lot of decimal places. I'd get a more precise answer, but let's just go ahead and assume we don't need that much precision. Over sine of 49 degrees, say 9 sine of 95.06 divided by sine of 49 degrees is going to say that side C is about 11.88. Come back to our list here to say alpha, beta, gamma, A, B, C. And we found alpha to be about 35.94 degrees. And beta was given at 49 degrees exactly. And gamma was about 95.06 degrees. And A was calculated to be, or was given to be 7. And B was given to be exactly 9. And C was calculated to be about 11.88. Now, one of the other ways that we can figure out if there's another triangle is that we can say that this first angle that we calculated here may have been may have not been acute. It may have been obtuse. It may have been greater than 90 degrees. So what is, if this were a reference angle here in quadrant 2, since sine is also positive in quadrant 2, what's 180 minus 35.94? That gives us what the other angle could be over here that has the same sine value. And then I'm going to add the known angle of 49 degrees. And oh, that's bigger than 180 degrees. So I'm going to stop. There's no second triangle. If I came out with less than 180 degrees here, then angle C could be a different measure, and I'd have an A prime, a B prime, and a C prime. I think that that's the way that the next one is going to work out. We'll see, because I think there's an example of each here. So I've got a 5, a 6, and a 7 to work out. So let's draw this. B is going to be 85 degrees. Side B is 6. Side C is 10. So this is B. This is angle C. This is angle A. This is little a. So big A which is the same thing as alpha to me, big B, which is beta, big C, which is gamma, and then little a, little b, little c for the sides. And this is 85 degrees. This is 6, and this is 10. So I want to now solve for C. Sine C over C equals sine B over B. So sine C equals 10 sine 85 divided by 6. C equals arc sine of that, 10 sine 85 divided by 6. Close that up. Okay, and I get an error in the domain because let's just show you why. 10 sine 85 divided by 6 is greater than 1. So there is no angle that can do that. So there's no triangle here. What that tells me is that this 6 is not big enough to come down and meet this side over here. Now let's prove that to you with the height of the triangle, like we talked about before, that h is equal to 10 sine 85. So what's 10 sine 85? It's going to be 9.96. This height is the shortest distance from this angle to this base. If this side across from the given angle is not longer than the height here, then it can't come down and hit the base because the shortest distance it has to travel is to make a right triangle here. If it's shorter than that 9.96, it can't possibly, it's going to be like a compass that swings this arc. It won't ever come down and cross that line that's down there. So there's no triangle. We have one more here, number 7. At 15 degrees here and 14 across from it. 18 is here, which makes that A and that C. And we're going to, let's go ahead and find the height. Like we've talked about before, 18 sine of 15 is going to be 4.66 approximately. So 14 is definitely bigger than that, but 14 is not bigger than 18 this time. It's not the biggest side. So I think that I'm going to be able to swing this 14 over here and make a second triangle. So let's go ahead and prove that with the other method here. But I'm going to set up A, B, C, A, B, C, and I'm going to set up A prime, B prime, C prime, little a prime, little b prime, and little c prime, where the primes are my second triangle. Everything that's given is the same in both triangles. So side A is exactly 18 and side B is exactly 14 in both of them. And angle B is 15 in both of them. Let's start off by solving for angle A since I have side A. So sine A is equal to sine B over B. Sine A equals 18 sine 15 over 14. And we're going to find the arcsine of that to say that A is about 19.44 degrees. My question then is, what if there A was instead, I'm going to try and draw this triangle here, A prime, B prime, C prime, 18, 14, like so. What if instead this was 180 minus that answer, and that I had an A prime of 160.56, and that with my 15 degrees added to it, if I take, that's less than 180, so 180 minus that answer is going to give me 4.44 up here. And I forgot to write down what this was here, but I've got it right there, 19.44. And let's take 19.44 plus 15 and say 180 minus that answer is 145.56 degrees. All right, now that I have all of that information, we're going to have to find C, and we're going to have to find C prime. So C over sine of C is equal to B over sine of B. So C equals 14 sine of 145.56 over sine 15. 14 sine of 145.56 divided by sine of 15 is going to give me side C is about 30.59. And I've got a little bit more work to do over here. So C prime over sine of 4.44 is going to be equal to 14 over sine of 15. That doesn't change because those are my givens. So side C prime is 14 sine of 4.44 divided by sine of 15 degrees. So this is going to be 14 sine of 4.44 divided by sine of 15 is going to be 4.19. And we had two triangles here. The only example of the four that I didn't show you is where we have one right triangle where the side across from the angle is exactly equal to the height. Then we know that we have one right triangle. So I'll summarize in a chart here. We have 0 triangles. When call that given angle A with the side across from it A, and I'm going to call this side B over here. And this side down here C, that angle C. And if there had been an angle B here, it would be down there. But in this case, we have that H is always equal to B sine of A in all cases. And if A is less than H, there's 0 triangles. If A is equal to H, there's exactly one right triangle. It's okay that normally we call C the right angle, and I'm not doing that here. I'm just drawing it like this. There's one right triangle, just staying consistent with A being the given angle and side A being the given side here, and B being the other side that is not the base. Now, we could end up with a situation where we have one triangle and hopefully I drew this big enough. I think I did, where I have angle A, H, and B, and A is greater than B is going to give me one triangle here, and I get two triangles when make an adjustment here. So I think that'll work. This when here's A and A. This is also A. This is B, B, C, C. If B is bigger than A and A is bigger than H, then there's going to be two triangles. So this side is big enough that it can come down. It's bigger than the height here, but it's smaller than this other side. It's going to hit this line twice if it were a compass that I swept an arc of that length. It's going to hit this base 2 times. So it's going to create 2 triangles. So this chart is the geometric construction way of thinking about it for those of you that used compasses in your geometry class to figure this out. You'll be familiar with this method. The other method that I used of always assuming that there's a second right triangle, trying to find the other angle with the same sine value, adding that to the known angle, subtracting from 180, and then seeing if you get another angle that makes sense, then there you go. That is the other method that is always going to work with trigonometry. All right. That's it for this section. This is one of the more confusing things that you're going to do definitely in this chapter, mostly for this entire class. This is one of the things that gets people is figuring out whether there's 0, 1, or 2 triangles. So go ahead and do plenty of practice problems from your textbook and anything else that your teacher gives you. Look up some extra practice problems online. I only did one of each example here, but you should do plenty of examples so you can get practice before you take your test. All right. Have a good day.